Hello everyone. So in this video we are going to see one program related to two-dimensional array. In earlier video I had already explained what is two-dimensional array and how we can store data when there is an array that is of two-dimensional. So before proceeding to this video, if you haven't watched by that video, then please do watch that video first so that you can understand how we can store data in two-dimensional array. So today the program we are going to see is we will be taking input from user for 3 by 3 array and we will be checking whether the array that user has entered is symmetric or not. So symmetric array simply means that if we divide the array in two parts, then both the sides should be same. For example, if I take one array like 1, 3, 5, 3, 7, 9, 5, 9 and 4. So you can see if I divide the array in two parts this way, then these two are same, this and this are same, and 9 and 9 are same. So if the array is present in this type of condition, then we say that this array is symmetric array. Else if in any other case it is not a symmetric array. So now we have to create the logic how we can implement this and see whether our array is symmetric or not. So first of all, we already know that whenever we enter data in array, datas are entered in sequential wise. Like first this element is entered, then this, next, next. This way we enter data in two-dimensional array. We know for entering data in array, we have to make use of rows and columns. So these are our rows and these are our columns. So in two-dimensional array, we generally make use of rows and columns like I and j. It's not compulsory we have to use this, but it is practice to keep this kind of variables. Now, if I say that a are of 0, 0, then the first 0 stands for the row and the second 0 stands for the column. If this is the value, that is 1 and 2, then it simply means that first row and second column, that is this one. This is 0 index 1 and 2. This is 0, 1 and 2. So first index, that is this one, and second index of column, that is this one. So 1 and 2 when we write, then this gives us value as 9 because we have 9 stored over here. Now what we have to do, we have to check whether this element is equal to this element. If we check the address of this element, then we can say the address of this is 0, 1. So 0, 1 should be equal to 1, 0. Should be equal to 1, 0. Next, this element is 0, 0, 2. So 0, 2 should be equal to 2, 0. If we see opposite to it, this is again 2, 0. This element and this element. So this is 1, 2. So 1 comma 2 should be equal to 1 comma 2 should be equal to 2 comma 1. And this obviously we will not be checking because this is the borderline of our symmetricity. So you can see here the values of I and j are getting interchanged. Here 0 comma 2, here 2 comma 0, here 1 comma 2, here 2 comma 1. Simply those are getting replaced. So for this we can simply create the condition like if my value of AR of I and j is equal to AR of j comma 1, then we will do some kind of operations. But what if we have the values of I and j as same, like in case of this 1, 7 and 4? So even at this condition, this will give us equal. Though we have to check, but for that we have to increment the count and check whether the value of count is equal to something, right? But instead of this, what I will do, I will change the condition. If AR of I and j is not equal to AR of j and I, then only I will increment the value of count. So ideally, if the matrix is symmetric, the value of count should not increase. I will take the value of count as 0 at the start of my program. And unless and until these two are not equal, I will not increment the value of my count variable. As soon as I find, if I take 6 over here, if I find these two values are different, the count value will increase 2 times. And at the end, I will keep another condition outside the loops that if my value of count is 0, then it simply means that my matrix is symmetric. And if my count value is not 0, then simply it is a symmetric matrix. So this is the main logic using which we can check whether our matrix is symmetric or not. Now let's see this output in BlueJ when we give different set of inputs in the array. So I will be taking input of array from user. For that I have created scanner class, and these statements will take input of the number from user. Then this set of statements will print whatever matrix the user has entered. I have created then another method which will check whether the matrix that user has entered is symmetric or not. So again I have to take two loops I and j, traverse them through all the elements of the array, and this is the condition which I explained earlier. If my value of count is 0, then it is symmetric matrix, else this is not a symmetric matrix. So if I compile and enter the numbers which I've shown earlier, that is 1, 3, 5, 3, 7, 9, 5, 9 and 4. So you can see 3 and 3, 5 and 5, 9 and 9. This is a symmetric matrix which we got as the output. But if we enter some different matrix like 1, 2, 5, 3, 6, 4, 9, 8 and last 7, then you can see 3 and 2 are not equal, 5 and 9 are not equal, 8 and 4 are not equal. So this should not give us the output as symmetric matrix. As we can see, it is not giving us. So this is how we can create two-dimensional array and perform actions using the index values of our array like I and j. So now if you have any other query in this program, then you can ask your query in comment section, and if you have any other questions that you are not able to solve, then you can send your questions on my mail ID. That's it for this one. See you in the next video.